Thank you for coming to the last startup pitches of the evening for today. Focus on Climate Hardware X. Now, let's see what these innovators have in store. A reminder of the competition rules. Each company and presenter has 3 minutes for their pitch. I will interrupt, don't take it too personally. I will interrupt if the 3 minutes are up. And then we have 2 minutes for jury questions. Any unlimited questions for the jury within those 2 minutes. Now, first to come on the stage is Jakob Stedman, CEO of Blykalla.
Thank you. Hey guys, glad to see you all. We build small nuclear power plants at Blykalla. They look like this. This is not an actual working power plant, they're a bit bigger, but feel it, it's 5 meters. It's significantly smaller than everything that's being in operation today. Because everybody wants nuclear power today, right? Even Ursula von der Leyen, the president of the European Commission, says it was a mistake for Europe to phase out nuclear. The problem is, it's really hard to get nuclear built. This is a way you typically build nuclear power. You have 10,000 people milling around on a site for 10 years. If the truck driver calls in sick, this guy doesn't get his box delivered from A to B. There's an enormous complexity. There's actually a book called How Big Things Get Done that look at all giga projects with a budget of more than $1 billion. Power plant, nuclear power plants, bridges, tunnels, Olympic villages. How many giga projects do you think in general were completed on time and budget, if you were to guess? 0? Any other ideas? It's a pretty good guess. It's actually 8% apparently. But if you also look at whether they realized economic benefits, it goes down to 1% of all projects. So that's why we at Blykalla, we don't build big things, we build small things. Our reactors are so small that you can fit them on a truck and transport it to the site. So you get rid of all the local construction work and instead have a China factory with quality control where you can build them with learning curves and continuous improvements. We believe that we can build nuclear power at half the price at 2 years instead of 7 years. So it's a vast improvement on today's technology. We use a liquid metal, lead, as a coolant, which has an excellent safety profile. Also means you can co-locate it more easily with other users like data centers. And we also close the fuel cycle, meaning that we don't deposit the spent fuel immediately like you do today. You actually use it again and again and again. We're the most advanced player in Europe, according to you don't need to take my word for it, according to the OECD, among the modern designs. And we're focusing on 2 markets now, United States and Sweden. We have Uniper, the German energy company, is an investor in Blykalla. So we're building a non-nuclear test facility on their nuclear power plant site in Sweden. And we're also building a demo reactor in the United States that we want to have done in the next 2 years. So it's an ambitious time plan, but this would allow us to prove criticality in a very short time. Then we'll develop projects in Sweden and the US and elsewhere. 100 people today, based in Stockholm, office in New York, setting up offices in Austin, Texas, and Idaho Falls as well. Oklo, if anybody of you know the American vendor, invested in our latest round, and we're now raising our Series B round, raising 150 million. So touch base if you want to talk with me about that later. This is our vision, building 100 reactor parks in the next 3 decades. Thank you for your time.
Thank you, Jakob, for that presentation. Does any jury have any questions? A few questions here.
Great. Thank you for the presentation. I'm curious how the approach that you're taking with liquid metal compares to other Gen 4 reactor architectures, like, for example, molten salt reactors, and why is it that you think that liquid metal is the right approach to be taking?
Yeah, so there are 3 or 4 different approaches to your question. We think liquid metal, and specifically liquid lead, which is the metal we use, allows you to have a very compact design, meaning they can really build a true small and modular reactors. Many SMRs aren't really small nor modular. It's an open secret in this industry. Ours are. So that's one of the big advantages with our metal. It also allows you, as a side effect, then to build much smaller and faster, which has all these other benefits.
Which industries are the first adopters, and how complex is the licensing?
Hyperscalers. If you had a question, industry's first adopters, hyperscalers have much more appetite than utilities or industrials. So that's where we're aiming at first. Sorry, what was the other part of the question?
Licensing, how complex is it?
Yeah, it's for a commercial park, it takes 3 to 4 to 5 years, depending on the country. For the first reactor we're doing in the US, that's a demonstration reactor. That means we can do that in a few months in the new American licensing regime.
Nuclear plants are famous for the secure measures. How you manage that, or how you approach in your project the measures of security?
Yeah, safety is the most important thing in our industry, and that goes for all types of nuclear reactors. Nuclear power is safe, SMRs, big reactors, everybody follow the same playing field, both from external attacks, but also from intrinsic safety events. And liquid lead, since, you know, if you go to the dentist and you do an X-ray, you get a lead apron, right, to protect you from the radiation. So lead is the best radiation shield known to humanity. So our design is extremely safe.
Perfect. Thank you, Jacob, for your presentation.
Thank you.
Next up for their 3 minutes, it's Alex IP, CEO and co-founder of CERT Systems.
Good afternoon, everybody. Thanks for being here. Hopefully we're not too much in between you and your drinks outside. So at CERT Systems, we're based in Toronto in Canada, and what we do is we convert carbon dioxide into essential chemicals without the use of fossil fuels. And so this is really important. I'm sure many of you flew into this conference to make business connections, maybe meet friends and family, but air travel is responsible for about 4% of global emissions. That is expected to go up as other industries can electrify, but it's very difficult to do that with airplanes. So the aviation industry is facing a number of different crises. So one is, of course, there are mandates in the EU and the UK that are forcing blending of sustainable aviation fuel. Another is that there's a lot of price uncertainty happening in the fuel supply chain. Jet fuel in particular, because there's not a lot of storage of it, has ramped up to almost twice the cost over the past few months due to things happening in the world. And so there's a few different ways that we can synthesize fuels that can drop directly into an airplane, but they're not all able to hit kind of all the different metrics that we need to reach those goals. So things such as using used cooking oil or biomass, they tend to be limited in the amount of total feedstock that's available. And if we look at using CO2, which is an abundant source, typically that requires using very high capex plants through Fischer-Tropsch in order to convert those. So what we are doing is using a process called ethylene to jet, where we can combine the best parts of different processes, convert CO2 into ethylene, and then convert that using well-known secondary conversion into SAF. And so we do this through a process called direct CO2 electrolysis, which takes only CO2, water, and electricity to produce ethylene. And so in our process where we do this, we actually can combine the capture and the conversion steps for the CO2 utilization. In that way, we eliminate the need for thermal energy to regenerate that capture fluid. And we don't require any sort of hydrogen or biomass input for this process. This also, because we're putting CO2 into the product, can avoid up to 5 tons of CO2 for every ton of ethylene. And this is something that we've done. Last year, we ran our first air-to-ethylene pilot plant at our lab. And this allows us to reach significantly lower costs than other sorts of SAF pathways. And even if you compare it against fossil costs lately, we project that we can get to below that price, and certainly when you include the penalties from the EU and UK mandates. What's also great about ethylene is that it's not just useful for fuels. It already has a $200 billion market, which we're focusing on as well to bring it into plastics and textiles. Our team includes some former executives from other clean tech companies such as Carbon Engineering and Carbon Cure. And we're currently raising a $3.5 million seed round. We're very interested if any of you would like to participate and join our mission to produce clean fuels from air. Thank you.
Thank you, Alex, for that. Any jury questions? One over here.
Hi, sorry. So in terms of cost of production from ethylene perspective, where do you stack up with traditional processes?
You're talking about the ethylene production. So there we're competitive today with conventional bioethylene production, which is a bit more costly, but then we see a pathway to bringing that down to approximately the same as fossil-based ethylene. Sorry.
I don't know if ethylene is recyclable or easily recyclable.
It is, and that's why it's actually really interesting for the plastic industry, is because polyethylene is the plastic that's most widely used from that. It's not easy to chemically recycle, and so if you want to use any virgin quality for like personal care or cosmetics, you can't really get virgin quality, so that's why you want to make something sustainable there. But because it's already used in a lot of mechanical recycling, people like it because you can easily just put that into the existing supply chain. It doesn't muck up any sort of mechanical recycling systems.
Perfect. I think there's another question here.
Are your customers ready for the solution? Do you have the first customer secured for the pilots?
Yeah, great question. So we have a customer, a German cosmetics manufacturer that's very interested in our technology. They want to use that actually in sustainable packaging. So for our go-to-market, we're going with the smaller volumes, which is in that packaging space, consumer brands, and that's going to show that we can do the core direct CO2 electrolysis piece and allow us to then scale up to the SAF volumes that are needed.
Any more jury questions? One quick last one.
In terms of capital expenditure and OPEX, how does that compare to the conventional systems when you plan to scale up?
Yeah, so when we did our modeling for the cost of plants, it is similar at the large scale, but what happens is we can actually scale down fairly easily compared with traditional thermochemical plants because it's an electrochemical process, and so it actually scales linearly rather than geometrically like the thermochemical ones. And so there we actually see a space for smaller, more distributed systems, and the CapEx contribution will be similar.
Perfect. Thank you, Alex, for your presentation.
Thank you very much.
And next up for his 3 minutes, we have Steve Krase, co-founder, CEO of Hephae Energy Technology Europa.
Thank you. Greetings. Hi guys, we founded Hephae in 2021 to enable super hot rock geothermal energy development. And companies like Fervo are leading the way in this exciting new field, demonstrating that we no longer have to rely on steam reservoirs. We can simply use the heat beneath the surface of the earth to generate electricity. The biggest challenge, as Tim states here, is that the technology required to accurately place these wells many kilometers below the surface is just not available. It's pretty much limited to 200 degrees Celsius, and we need to go hotter, much hotter. Now, World Oil have recently shared the news that we've broken this 200 degrees Celsius barrier, and we're demonstrating this in a live drilling environment for Fervo at their Cape Station installation in Utah next week. So why is temperature so important? This chart illustrates the relationship between increased rock temperature on the horizontal axis and reduction of LCOE on the vertical axis. Currently, Fervo are drilling at 200 degrees Celsius rock, and if they can get down to 250 degrees Celsius rock, they see a reduction in LCOE of 50%, and this will continue as they drive towards 400 degrees Celsius. This is an image of the Hephae Pandora 210 drilling system that has broken the 200 degrees Celsius barrier with a survival temperature of 230 Celsius. This robotic system sits behind the drill bit and enables precise wellbore placement that is required by all developers. In addition to the reduction of LCOE, developers like Fervo are estimating a savings of $1 million per well due to the elimination of the need for expensive cooling techniques. So how did we achieve this? Well, we asked a team of young engineers here in Bilbao to start with a blank sheet of paper and develop a new concept to break this barrier. The result is a radical new patented system designed to withstand the high shock and ultra-high temperatures associated with drilling these wells. With this new concept, we not only have broken the 200C barrier, but have a clear path to 300 degrees Celsius by 2030. We've raised $13 million to date and are currently raising a $6 million Series A to support commercial field operations and to build out a fleet of tools that will enable us to address the needs of Fervo, Mazama, and others and achieve cash flow break even by the first quarter of 2027. If we assume a modest contribution from geothermal to the energy mix, we anticipate that next generation geothermal would be larger than oil and gas by 2040. And assuming this increase in drilling activity and a conservative market share assumption of 35%, we're projecting annual revenue in excess of $2 billion by 2035. We have a diverse team headquartered in Houston, Texas, with hundreds of years of experience in developing downhole technology, coupled with an amazing team of younger technologists and high-tech infrastructure based here in the Basque Country that are dedicated to breaking barriers and not afraid of tackling the impossible. With that, I would leave you with this quote from Mark Twain, and thank you for your time, and happy to answer any questions.
Thank you, Steve. Any jury questions? There's one over here.
Yeah.
Who are your customers and what is the business model?
Well, the customers are Fervo Mazama. They're the first ones drilling these next generation geothermal wells. The business model normally would be we would sell equipment. We're planning on being an OEM, but because of the depressed drilling market in the United States right now, our customers that we would normally sell to just don't have any cash. So we have a rental model, at least for the next 12 months, to Fervo Mazama. Pricing is in place, and as I mentioned, we'll be deploying tools next week.
Any other jury questions? One here.
How much CapEx do you need to scale?
How much CapEx do we need to scale? We're looking at $6 million, $3 million to build out a fleet of 12 tools, $1.5 million for working capital, and another $1.5 million for continued IP development. That takes us to cash flow break even Q1.
Any last jury questions? No? Thank you, Steve, for your presentation.
Thank you.
Thank you. Up next for the startup pitches, we have Hanne Martinussen, CEO of Hydrogen Mem-Tech.
Good afternoon, everybody. I'm from Hydrogen Mem-Tech. We're based out of Trondheim, the tech capital of Norway. And today I will talk about how we enable the full potential of low-carbon hydrogen and why purification will unlock new and emerging markets. Hydrogen is considered one of the cornerstones in the energy transition. However, hydrogen is often not produced in a sufficiently pure form. It can come from methanol, ammonia, biogas, natural gas. Hydrogen produced from these alternative energy carriers and fuels often need purification in order to meet the required purity levels depending on the user application. As a result of this, we see an increasing demand in purification technologies and systems. It's in this gap, the extraction and purification layer, that Hydrogen Mem-Tech has positioned ourselves. And we have the ambition to be the world leading within purification technology on the high purity market. Here is our solution to the purification challenge. A thin palladium-based membrane that selectively lets hydrogen go through while blocking all other gases. Palladium has been known for decades for its 100% selectivity towards hydrogen. What we have done is industrialize this in a compact, modular, and scalable product. And we have a broad patent protection and have piloted this in several customer projects. Our sales is about to take off via our partnership model. We deliver through new and established players in the value chain, being system integrators, EPC contractors, technology providers. And we see increased traction in the market segments, being maritime electrification, distributed power generation, and industry. We have a great team working out of Trondheim, innovative team that is dedicated to work towards the ambition of being the lead on purification technology. We have also a very good support from leading industrial players and clean tech investors, as you can see on the bottom. And we're now raising 5 million euros to support our continuous partnership and sales work. Thank you very much.
Thank you, Hanne, for that. Any jury questions? Down here.
What would you say is your key differentiating factors amongst other hydrogen competitors?
Okay, so there's two ways to answer that. One is we have competing technologies. We have a passive system that needs no maintenance. So very low maintenance and service requirements. And the other is high purity. We can deliver fuel cell grade purity. We also have a competitive within the same technology sphere. We have planar membranes that is very scalable and compact that can go easily into, for example, containerized systems.
I think there was another question here.
So just a maybe question of understanding. You do focus on purification. You do not produce hydrogen.
Correct.
Okay, where do you get the hydrogen from? So do you insource it from particular countries, or do you work on site where hydrogen is produced locally?
Good question. So also two answers to that. We can install our purification system in a refinery or a process plant where you have hydrogen in your stream, and we can extract or purify hydrogen that you have there. The other is, for example, for the maritime electrification, you can fuel with methanol on board the ship. You reform it, and you need to purify the hydrogen before it's fed to the fuel cell. So that's it, yeah. Thanks.
And last jury question.
Okay, very fast. I wanted to ask you, who are your clients and what is your business model? And
yeah. Okay, so we work through partnerships. We're an OEM delivery to EPC contractors or technology providers. Our customers are, for example, those who containerize and develop power packs to make electricity out of methanol, or refineries that need to extract hydrogen. So it's a very broad and agnostic model and technology that we have.
Perfect. Thank you, Hanne, for your presentation and pitch.
Thanks.
Next up, we have Cecilie Drange, CEO of Sandcatch Solutions.
Thank you. Hi, we are the efficient shit shoveling company. You see, biogas plants are set up to run continuously. Unfortunately, they do not. Over time, grit builds up, choking the efficiency of digesters, which results in shutdowns lasting for weeks with no production and no revenue. Across Europe, loss is valued at approximately 500 million euros, so we're talking major money. So, Sandcatch Solution has adopted technology from the oil and gas industry that we've used on live wells for decades, and we are now able to remove this grit without shutting down production. This means that we've de-risked our engineering process. By using this coiled tubing methods, we have validated the methodology, the physics. We know this works. That ensures that we're now looking at not making technology work, but scaling our solutions correctly. So we're offering two different business lines, the service line and the sales line, based on different segments of the market. And our scalability is inherent when you look at this flywheel. So we've started at proof points, and we're now into commercialization, and we've even had our first repeat customer. And we've built a large international pipeline, and our first international job is going to be towards the end of this year. So we have an experienced team and people used to working in this nasty environment. We've got offshore oil and gas engineers, 20 years experience, who are bringing a risk profile and a process mentality into the biogas industry that has been missing. And our operators are farmers and process technicians. I'm talking people who have real life experience. So we're soon opening our 4 million euro raise. That's to scale our fleet across Europe, to ensure that we have repeatable, predictable deployments. And since this is hardware, our model supports an asset-based expansion alongside equity for growth, ensuring that we won't over-dilute. And yes, we do have a measurable impact. 20% more gas produced, 50% less waste delivered to landfills. But the most important, we use the existing assets that are already there. We provide more renewable energy from existing infrastructure. And you might ask, why now? Well, in these unstable energy times, with the political leaders that we have in place, we are offering a quick rollout to homegrown energy. So if you want to be part of an efficient shit shoveling company, let's talk.
Thank you, Cecilia, for making us smile as well.
It's the end of the day.
True. We do need that little uplift. Any jury questions?
Yep. Hi, thank you for the pitch. I'm curious how you think about financing the fleet as you're working towards scaling the company.
Yep, we have two options, either by debt or by doing, word I'm looking for in English is leasing options.
Okay, all right.
I think there's another question here.
Hi, thank you for the pitch. €2 million investment per installation you mentioned. You mentioned €2 million per installation. What's the payback time for your customers?
Depending on how you operate it, these comes in sort of doing jobs periodically. So for a sales unit, I would probably say around 14 months. For a service unit, it'll probably take 18 months.
Any other jury questions? No? I think you left it all clear in your presentation then. Thank you very much. Next up, further 3 minutes, it's Nicolas, Heuze, CEO of Sweetch Energy.
Right, good afternoon, everyone. So about Sweetch Energy, we're basically building a new category of baseload clean power from osmotic energy. You probably don't know what it is, so simply, every time fresh water from the river meets the salt water from the sea, it liberates osmotic power. So this is everywhere in all deltas and estuaries, and it's known for decades, but so far, the technology to produce electricity out of it, the economics didn't work, right? And so this is the bridge that, the gap, that we're bridging at Sweetch Energy. So, snapshot of the company. We're a French company, you can hear my accent. We have about 60 employees, very smart people. We raised 32 million euros so far. We're preparing the next fundraising that will be up to 40 million euros. And we have fully owned technology with a 14 patent family. And we have a clear roadmap. We already have a demonstrator live in the south of France. We're preparing the next pre-commercial project by 2028. And we will be first commercial planned by 2029, 2030. Why we do that, I think you all know it. We need more and more power. We are putting together more and more power globally, but most of it, especially renewable, is not firm or reliable power. It's mostly wind and solar, which is great, but it's weather dependent or time dependent. And so what is needed now, and the shift is really toward firm, clean, reliable power, and this is what we do with osmotic power. This is a massive opportunity, totally untapped as we speak. There are 300 gigawatt power capacity that can be deployed worldwide. And so far, the simple reason why it's not done is because of the cost. So our mission is really to bring the cost down. And the enabler for that is our technology that we call iNOD, for ionic osmotic diffusion, nano-osmotic diffusion, simply because we are using new materials that we've developed. These are nano materials, biosource material that we've developed internally, and we combine this material with also innovative osmotic stack design. So this is something that we've done by ourselves, and that we've completely protected. But this is not a science project. This is a real-life project. We already, as I said before, have a first demonstrator that is in operation in the south of France. We are learning. because technology is great, but you also need to learn how do you operate an osmotic power plant. This is what we do every day so that we can deploy at very large scale. We are also demonstrating that not only is it reliable, it is clean, and it is safe for the environment. All water that we're using, fresh and salt water that we're using in the system, flows back to the river. Thank you very much.
Thank you, Nicolas, for your presentation. Any jury questions? There's 2 here.
Sorry. Can you talk about the quality and the consistency of the water that you end up using in the generator? Does it have to be exactly the same level of salinity and purity on the fresh side? And also, the second question would be on the cost side. I mean, one of the big issues around osmotic and many of these has been low energy density and very high cost on the other side.
Good point. So obviously, the system needs to be flexible to work with different type of water, because whether you are on the Rhone River in France or the Po River in Italy or elsewhere, there are different type of water. So this is exactly what we are learning in our demonstration plant in the south of France. And I must say that obviously we're learning. It's not working always as we expect, but so far so good. We can see that the system is quite flexible. Sorry, your second point was about?
On the cost side.
Yeah, cost. Cost is the point, right? I mean, to make this thing competitive, there are 3 levels. One is technology, and how do you increase the efficiency of the technology? Second is industrialization. How do you produce your membrane that are the core of the system, and you do the stacking? And the third level is operation. How do you make sure that your net power is as high as possible, meaning how do you reduce the energy you self-consume to circulate the water into the system? We are working on these 3 levels. They are equally important, and so we think that with our first commercial plant, we will reach at first 100 euros per megawatt hour as an LCOE, and then it will further reduce as we scale up. You know, this is economic of scale, you know, that will also will take advantage of.
Perfect. Thank you, Nicolas. That's enough.
Thank you very much.
That's it for the jury questions. Thank you, Nicolas, again. Next, we have Dr. David Kingham, founder and senior advisor at Tokamak Energy.
Right, thank you very much. Tokamak Energy is a company focused on accelerating development of fusion energy while delivering exceptional value for shareholders and new investors, and delivering unique capabilities to customers and strategic partners. We've built and demonstrated a world-leading compact fusion reactor, achieving plasma temperature over 100 million degrees, and as a result, attracting a $52 million research contract from US Department of Energy and the UK government for our device based in the UK. We've built and demonstrated record-breaking high-temperature superconducting magnets. We've scaled them up to the field strengths and current densities necessary for fusion, and we have this week announced a £70 million, 90 million euro contract from UK government to develop superconducting magnets for fusion, so government as customer. As a snapshot, we now have 300 employees, 400 patents, teams in the US and Japan as well as the UK, the ability to design and manufacture high-temperature superconducting technology at scale and in large volume, and a rapid transition now from investor-funded R&D to profitable growth. The first few years of the business were all about achieving technical milestones, validation of technology. The next few years are all about commercial goals and achieving a global lead in high-temperature superconducting technology. We have an eye on the main prize of fusion energy, but we know we can win other large prizes with our high-temperature superconducting technology along the way. For example, scientific instruments for life sciences, where we have a collaboration with a major Japanese partner aimed at a billion-dollar scale market. Data centers, where we have a unique superconducting power transmission technology. propulsion systems, including electric aircraft, where we work with Airbus, and defense technologies, where we work on a DARPA project with General Atomics on submarine propulsion. All these technologies arise because of the challenge of developing technology for fusion. What this means is we have an unbeatable offer for investors who can see progress and commercial opportunity in fusion, but don't really like the long timelines, the high technical risk, and the huge capital requirements. In summary, we have a profitable path to develop commercial fusion energy. Thank you.
Thank you, Dr. Kingham. Are there any jury questions? One here.
So you already have quite a big investment and over 300 people in the team. Why do you still call yourself a startup?
It feels like a startup. You know, we're just in that transition from completely pre-revenue 2 years ago to a few million euros of revenue in the last year to a projected 30 million euros of revenue this year. So that very difficult but very rapid transition from investor-funded R&D to products for customers.
How much of the focus is on the R&D for fusion versus the high-temperature superconductors in terms of, you know, more of a business opportunity versus R&D? Like, how do you say that split in terms of resources?
Yeah, so we see investor money now going into research and development and exploitation of the superconducting magnet and superconducting busbar technology. And we see governments as customer to fund ongoing fusion research.
Any more jury questions? No. Thank you, Dr. Kingham.
Thank you.
And last but not least for the day, it's Rait, Maasikas, CEO of Up Catalyst.
Good afternoon. I'm Rait from Up Catalyst from Estonia, and I will tell you how we are solving one of the critical raw material problem for Europe. When it comes to batteries, everybody talks about lithium. But the single largest component of a battery is actually graphite. Graphite makes up 25% of the battery weight. Graphite generates 40% of battery carbon footprint. And over 90% of that material is coming from China. So we're building our energy, we're scaling our energy transition on a material that we don't control, we can't afford in terms of the carbon footprint. So this is the hidden problem of energy transition for what there is currently no local solution. At Up Catalyst, we are building a solution for this problem. We are turning CO2 emissions into battery-grade carbon. Using our molten salt-based electrolysis, we are able to turn captured CO2 emissions into battery-grade graphite and multi-wall carbon nanotubes. So CO2 stops being a waste stream and instead is a feedstock for building up a supply chain for local critical raw material. Why is it so relevant right now? First, we see increase in not only in EVs but also in grid storage demand. Second, we see big demand from regulation to have a better secure supply chain. We see regulations like CBAM expanding to the next areas. We see local content requirements being introduced. We see talks about tariffs. All of that is basically showing that having the local critical raw materials is not just a nice to have, but it's a real necessity. Why is our solution really interesting? There are 4 reasons. First, it's the efficiency. When we generate our process, we operate at a temperature around 600 to 800 degrees. whereas in the traditional method, it's about 3,000 degrees. Lower temperature means lower energy and lower cost, first. Second, we use less concentrated CO2 that is easier and cheaper to capture. Third, our technology is modular and scalable, so we can build it up anywhere where there is a supply of CO2 and electricity. And finally, because we use CO2 as a feedstock, then the carbon footprint of a product at scale will be negative. So where we are? So we are not anymore a lab project, so we operate a pilot facility in Tallinn. So far we have validated that with this method we can produce battery-grade graphite, which is a big milestone hit. We're also right now working on applications to customer applications for several multi-volt carbon nanotube applications. And we have sent out more than 60 samples, even more is in the pipeline. So it's not anymore the question of the technology, but it's the question how fast can we scale it. We are right now preparing for our Series A round of 10 million euros. So I invite you to join in building up the European supply of local critical raw material. Thank you very much.
Thank you, Rait, for the presentation. Do we have any jury questions? There's one here.
Great, thank you for the presentation. I was curious if you could speak a little bit about unit economics and how you compete on price with graphite sourced from China.
Yeah, absolutely. So it's a commodity product. The price is the most important thing. We can compete with the Chinese price, assuming similar rules. And why we can compete with the Chinese price is the following. First, we use CO2 as a feedstock. This is actually cheaper than using the petrocoke unit by unit. Second, because our process runs at much lower temperature, we can also beat the energy efficiency. And third, we have also looked at when it comes to the CapEx calculation, we should be able to build a simpler system. But of course, if you look at the Chinese system, of course, there's a big support for actually building it up, which is something that we'll also need in Europe. But otherwise, basic fundamental economics is much favorable for this method.
One more jury question. Oh.
What grade of CO2 are you looking at? Like, do you need pure 97% grade CO2?
Yeah, so
that's one. And the second one is with the EU ETS price also, the CO2 prices would be quite higher, no? Depending on biogenic or non-biogenic CO2. And how does it compete with the other fossil sources?
Yeah, thanks for these two great questions. First, was around the CO2, right? So we use, first of all, 4 units of CO2 to produce 1 unit of end product. It was about concentration. So yeah, we need, we can basically also pump air through the system, but it's not efficient. So where it becomes economically efficient is around 98%. So it's much less than, for example, for segregation. And the last percent is the most expensive one. Now, when it comes to the CO2 pricing, so we are not looking at the ETS system at the moment. So we're mainly looking at the bio-based CO2, and it's essentially the question of capturing cost. And then, since we don't need to have such a high purity, then also this cost is pretty reasonable given this model.
Perfect. Thank you, Rait, for your presentation.
Thank you very much.
Thank you to all of our pitchers and our jury members. That brings us to the close of day 1 here at the Energy Tech Summit 2026 Tech Talk stage. We've seen sharp ideas, strong pitches, and plenty of energy throughout the day. Now you guys have some time to rest after a lot of mental energy wasted today. I mean, no pun intended, kind of, maybe. We appreciate everyone who came today, who stepped up on stage, who gave us brilliant innovation pitches. We'll be back tomorrow with more. In the meantime, enjoy the city tours. The sun, it's not very common here in Bilbao for the sun to come out, so do enjoy that. And don't miss the evening gathering at the Guggenheim Museum, not too far from here. That's it for now, and see you tomorrow.